we were talking last time, the class that we did not record, about reading potential energy curves. And we started about talking about the relationship between the force that's generating the change in potential energy and the potential energy itself. And what did we find out that f of x was equal to? Yeah, negative du dx. Okay, and we talked about the different types of points we can have in a potential energy curve. We talked about turning points, we talked about equilibrium points, and we did one example problem, sample problem 13, I think, where we basically just used this formula. And now we're going to do sample problem 14, and then I have an actual AP question for you to do, and then a AP review question for you to do. And then we'll be done because tomorrow's the test. So let's do sample problem 14. If somebody wants to read it while I try and draw the curve that goes with it. Okay, so the curve looks something like this. Note that around point B here, that is not supposed to be symmetric. Nor is the curve supposed to be symmetric around point D. And I have done my best. I probably draw better on the board, but you know exactly what symmetric means. It's not a parabola. It's not the same. It doesn't have the same slope on both sides. It is not symmetric around that point. Okay, so everybody got a curve? Okay. All right, so part A says at each point we need to decide whether f of x is positive, negative, or 0. So how would we get force from a potential energy versus position graph? Maddie. Right. Okay. So as Maddie said, du dx really means slope. So we can look at the slope at each of the labeled points. And then whatever that slope is, positive, negative, or 0, we would flip it because the force is going to be the negative of the slope. Okay. So we'll kind of have to flip back and forth here. But if we start at point A, what can you tell me about the slope of u of x? Positive or negative or 0? Okay, so it's going to be greater than 0, which means that the force at that point is going to be what? Negative, okay, because if the slope is positive and the force is the negative of the slope or the derivative, then the force will be negative. How about point B? What's the slope of u of x at point B? Yeah, it really should be at the top, which tells us that f of x is what? 0. How about point C? What about the slope? Okay, so the slope is less than 0. Well, the slope is negative, so what's that going to tell us about the force, Priya? The force is going to be positive. Okay, because remember that the force is the negative of the derivative or the slope of the potential energy. All right, we can still see point D up here. What's the slope of u of x going to be at point D? 0 again, which tells us that f of x is going to be also 0. Okay. If we look up at point E, what's the slope going to be at point E? Greater than 0 or positive. Good. So that tells us that the force is going to be negative. And if we go up again and look at point F, what do we have at point F? It should actually really be 0. This is going to come to a level, okay, a constant value. So even though it's kind of hard to see, the slope at F should be equal to 0. So the force at point F will be equal to 0 as well. Okay. All right, so everybody see how we're going back and forth between those two? All right, again, pretty straightforward once you get the idea down. Okay. All right, so what does part B ask us for? Okay, so we want to know where f of x is the greatest magnitude. So what does that mean we're looking for? The steepest slope. Let's write slope again there. On the u of x curve. Okay. So I know what the answer should be based on the original drawing, but we'll go by whatever we think it is on the drawing that I made this time. So if we go back and look, it might very well be at point C from the way it's drawn because it really does look almost vertical. Okay, so I can definitely go with that point C has the steepest slope. So therefore the force is biggest at point C. Okay, makes sense? All right, so there was one more part to this. Part D, or no, part C, excuse me. And what does part C ask us about? Equilibrium points. So what do we remember from our conversation yesterday about what has to happen at an equilibrium point? Zoe. Yeah, the force has to be 0. So based on our picture here and our results, which points should be equilibrium points? B, D, and F. It doesn't ask us to, but do we want to try to figure out what kind of equilibrium points these are? Who, what, how? Oh, it does? Okay. Stable, unstable, or neutral. So it does ask us to do that. So how about, let's start with F, because F is probably the easiest one. What's F going to be? Not stable. F is going to be neutral. Okay. We can talk about neutral means that when it comes up, it's going to have just enough energy to ride up until to F. And then the force is zero kind of on either side of F. So once it's there, kind of, I like to think of it as a rolling ball that rolls up onto this shelf. There's no reason for it to move. There's no force. Even if it gets blown on a little bit, it's going to stay there on the shelf. Well, hang on. So, well, no, the whole thing is that even if it's moved a little bit, the force is still zero around it, as opposed to stable and unstable, where if the particle gets perturbed a little bit, so it moves, its position is disturbed a little bit, all of a sudden it leaves that point and there's a force now. Okay, so let's talk about B. So we can kind of think about it as if we nudge B that way in the positive direction, which way is the force going to be? How do we know the force is going to be positive? Because the slope is negative and the force is going to have the opposite sign. So if we move it, if it gets nudged that way, yes, it's going to be unstable because the force is also that way. You can kind of think about it as sitting at the top of a pointy bowl. Yeah, and it'll drop either way, because if we displace it a little bit in the negative direction, again, the u of x curve has a positive slope, so the f will be negative, and the f will point in the same direction of that as that motion, and it'll take the object further away from the equilibrium point. Okay, so B is going to be unstable. And that leaves us with D, to talk about. Okay, what kind of an equilibrium point is D going to be? Why is it going to be stable? Okay, so if we push it in the positive direction, the slope here is positive, which means that the force points in the opposite direction, and it'll bring the particle back to the equilibrium point. And that's what makes point D stable. If we nudge the particle in the negative direction, now the slope of u of x is negative, so that means that f of x is positive, and it'll work to counteract the direction of that disturbance. So D will be stable. I would not, if I were you, make the assumption that you will have one of each every time you look at a graph. Okay? Well, remember, this is not going to be on tomorrow's test. Okay, it'll be on the mini test that we have after break. What? I think you guys are doing okay. All right? Okay. So that aside, make sure, I think this, well, Priya's gone. I will check, but make sure that you read the rest of chapter 8 for when we come back from vacation. Okay. I will. I thought I already did have the reading. and I will check. But we have to do conservation of energy with friction. And we will do that when we get back, and then we'll have at some point after everybody's back from break and everybody's caught up, we'll have a mini test on what we did with the potential energy curves and with conservation of total energy. Okay? But right now, what we're going to do, and I'm just going to write this on here and then I'm going to turn the recording off for a little bit, is we're going to do from the AP, we're going to do the 1997 exam, mechanics number 1. And then on the back of the sheet that I'm going to give you in a minute is question number 3 that's just from an AP review book. And I just like to give you that 1997 mechanics question so that you know that you are in fact capable of doing problems that are on the AP exam. Okay?